Good morning, good afternoon, good evening. Welcome back to Chapter 6. We just finished talking about cellular respiration. We just finished talking about Step 3, which is the electron transport chain. Remember that the electron transport chain moves electrons through carrier molecules. The energy in those electrons is used to force hydrogen ions that were pulled off of the sugar molecule, to force those hydrogen ions into a very narrow space. If it's a narrow space, it doesn't take many of them to make them feel crowded. Because of diffusion, if we have a lot of something in one area and not much of it somewhere else, what do they want to do? They want to go from where there's a lot to where there's not much. So those crowded hydrogen ions want to get out of that narrow space. And the way they get out is by pushing through a molecule called Atp Synthase. The name literally means the enzyme that makes ATP. The way you make ATP is you put a phosphate onto ADP. 2 plus 1 is 3. I make ATP. I put a phosphate onto adenosine diphosphate, making it a triphosphate. And we talked about it. We said that the adenosine diphosphate is the charger, and that the last phosphate is the battery. Forcing the hydrogens, forcing their way through ATP synthase, is what forcefully puts that phosphate back onto the ADP. It's what puts the battery back on the charger, so I have a charged battery. Lots of poisons work by interfering with the electron transport chain, and we saw in the slide before this that the electron transport chain makes 34 of the 38 ATP that you get from one molecule of sugar. It makes most of it. It makes like 90% of the energy, 90+% of the energy that you get from the electron transport chain, or from one molecule of glucose. Don't forget, what was the molecule that took those electrons away? The molecule that took those electrons away was oxygen. If oxygen isn't here, then this process stops. So if there's no oxygen, I don't shove hydrogen ions into the space. If I don't shove hydrogen ions into the space, then they don't want to get out. And if they don't want to get out, they don't push their way through the revolving door. And if they don't push their way through the revolving door, I don't make ATP. I don't shove phosphate onto ADP. If oxygen isn't here, then the electrons get stuck. They don't move any farther. They don't push any hydrogens out. And now I can't make those 34 ATP. So several poisons work by binding to those carrier molecules, basically being a roadblock in the process of the electrons moving from one molecule to the next. Rotenone will bind to one of those carrier molecules the electrons pass through. Cyanide and carbon monoxide. You've heard of carbon monoxide? The way it kills is by being a roadblock. It literally stops the electrons from traveling down that electron transport chain. And if they don't travel, hydrogens don't get pumped into the narrow space. They don't want to get out of the narrow space. We don't make ATP. DNP was a molecule, is still a molecule, but it was used as a weight loss drug in the 40s. You take it, and what it does is it makes your mitochondria inefficient. They're not able to make all the energy from the food that you ate. Well, what happens when people take a little something and it does a little bit of good? They take more. Some is good, more is better. So people killed themselves by taking too much DNP. Basically, they caused themselves to starve of ATP even though they had plenty of food. Because what does it do? It does the same thing these others do, which is break the electron transport chain. Oxygen has to be present for us to do the electron transport chain. But not all organisms have to use oxygen. And to be fair, there are some organisms that can't use oxygens. And these are called obligate anaerobes. If you have an obligation, what does it mean? It means I have to do it. I can't get out of it. I must do it. What does air mean? Well, it means air. In this case, we're going to take it to mean oxygen. What does it mean when you put a or an in front of anything? It means without. So obligate anaerobes must live in the absence of air. They have to live in the absence of oxygen. If you expose them to oxygen, it will usually kill them. There are several species of bacteria that are poisoned by oxygen. They live deep down in mud, in swamps, in the bottom of the ocean. They live in a lot of places. It's almost always mud. But they live in mud where there is no oxygen present. These things called obligate anaerobes. Some organisms that can use oxygen can temporarily go without it. And a better answer for this is they can deal with less than they would like to have. Anaerobic fermentation, not using air to burn energy. There are two methods of it. You are an animal, so you do what's called lactic acid fermentation. We go all the way back to step 1, glycolysis. We're going to do this process of glycolysis where we get 2 ATP and we make 2 NADHs. And then we get this thing called pyruvate. But because we don't have oxygen, we can't do anything after step 1. We can't do anything after step 1. We have to do step 1 and stop. And remember what we talked about with feedback inhibition. Remember what happens when the product of a pathway builds up? What does that do? The answer is it inhibits the pathway. So if my product of my pathway, which is NADH and pyruvate, remember I'm using up the ATP because I need it for energy. If I don't have oxygen, I can't send the pyruvates to primer phase. If those pyruvates build up, it's going to stop glycolysis. This is the only way at the moment I can get energy. So I have to continue to do glycolysis. So I've got to get rid of that glycolysis and turn it, or that glucose rather. I have to get rid of that pyruvate rather, so I can continue to do glycolysis. The way I get rid of the pyruvate is converting it into something called lactic acid. That reforms my NADHs, so I can keep doing this process of glycolysis. When would you do lactic acid fermentation? It's when you're working out really hard. It's when you are running. You ever notice that when you run, you don't necessarily breathe hard while you're running? When do you really breathe hard? And the answer is you breathe really hard after you're done running. That's because what you did was you incurred oxygen debt. You weren't in a zero oxygen environment, but you were in a low oxygen environment. What you were doing is you were burning more energy than you could take oxygen in to burn. So you went into what's called oxygen debt. And what some of your cells did to keep making energy is they converted from doing cellular respiration to just doing step 1 and making the stuff called lactic acid. You've worked out to the point to where your arms are shaking. You couldn't move them anymore. And that was because of lactic acid buildup. There was not enough oxygen to make the energy to move your muscles. Lactic acid buildup. Some bacteria will do lactic acid fermentation to make cheese and yogurt. You can do it with soybeans to make soy sauce. And lots of cultures will turn cabbage into a sour product. Sauerkraut in German culture, kimchi in Korean cultures. Lots of cultures will ferment vegetables so that they keep, so they last longer. And the way you ferment them is by making them do cellular respiration without being able to finish it. And so you turn into this stuff called lactic acid. Lactic acid buildup, oxygen debt. You can look at that person and clearly tell they're exhausted. Why are they exhausted? They're exhausted because they were probably running and they were using more oxygen than their body could take in. And because they were using more oxygen than their body could take in, they were exhausted. They have to repay that oxygen debt. And that's why when you get done running, you huff and puff. Doing lactic acid fermentation is not the only way of dealing with low oxygen. There is something called alcohol fermentation. There are some organisms that can live with or without oxygen. We said that obligate anaerobes have to live in the absence of oxygen. What are you? You are an obligate aerobe. you have to live in the presence of oxygen. There is an in-between condition, and this in-between condition is called a facultative anaerobe, which means these organisms can live without oxygen, but they would rather live with it. And the reason why they'd rather live with it is because if I don't have oxygen, I can't make 36 of the 38 ATP I could make from my sugar molecules. So I'd much rather have oxygen to make all that extra energy. Yeasts are facultative anaerobes. They don't do lactic acid fermentation. They do alcohol fermentation. We start off with the same process. We start off with glycolysis. We still cut up a glucose molecule. We get ATP out of it and NADHs. And ideally, we would want to send those NADHs to step 3 and do the electron transport chain. But what's the deal here? We don't have oxygen. If we don't have oxygen, we can't do the electron transport chain. I've got to get rid of this pyruvate so I can keep doing glycolysis. And the way the yeast will keep doing glycolysis in a low or zero oxygen environment is it will do this process called alcohol fermentation. It will cut one of those carbons off, release it as carbon dioxide, and convert it into the stuff that we call ethanol. Now, you've heard the term ethanol before. What, you mean like gas? I mean like the stuff they put in gas. Most gases that you buy that say ethanol gas is between 10 to 15% alcohol and 85 to 90% actual gasoline. If you've ever heard of an E85 car, it's because they can burn a special kind of gas that is 85% alcohol and 15% gasoline. That is specifically the kind of alcohol that you drink. This is how you make wine. Is you put yeast in grape juice, fruit juice, and you put it in a low oxygen environment, and once the oxygen runs out, it switches from doing cellular respiration. It switches to doing alcohol fermentation. So it can get those 2 ATP and stay alive. But it would really rather have oxygen so it could keep doing the full process. Those yeasts that are able to do alcohol fermentation typically die at about 14% alcohol, which is why wines tend not to be about 14% alcohol. Because they can only keep doing alcohol fermentation until the alcohol poisons them. And alcohol is a poison, and you know alcohol is a poison. How do you know alcohol is a poison? What happens when you drink too much of it? You throw up.